Hi, I'm Luke Mateo, and I'll be doing project 2. So first, we're going to start by opening up the Fluent, the project. This is project 1. Open up the geometry of the project. So here is the surface that we made previously. I'm going to go to the sketch. Go to sketching. And we're going to make the flat plate today. So I'm going to make a construction point because we want to center the test section. So it's going to make it midpoint of this. So now we're centered of those lines, which is a center line. Draw a line, and we'll make sure. Pretty sure it already. Yeah, it's vertical. Then we're going to draw a line here. And we're going to make sure that this line is coincidental to that line. And then we're going to draw the flat plate over this. Actually, I'm going to undo that. We're going to draw it above the line. And then I'm going to put a dot on it. A construction point. That should still work. And constraints. Midpoint. This dot with this line. So those are constrained. And I'm going to do the same thing again. Or not midpoint. Concentric. That's what I want. Or do I? Well, I want coincidental. Concentrics or circles. There we go. And then we're gonna well, whoops. Delete this line. Delete this line. And then I'm gonna do that and generate. Now we're done with the sketch. It's at the center of the test section. Oh, I did not dimensionalize it. We're gonna undo. Here we go. Dimensions, general. And this is B10. We wanted this to be 0.6 inches. That's not. It should. Going. Oh, because the line's not there. No. Undo. There we go. Now we can dimensionalize it. And now it should stay. And the 0.6 is 1/10 of the test section. It's 6 feet or 6 inches. Yeah, there we go. Perfect. And after that, delete this line. I'm gonna delete this line. And now we're gonna go to the model and generate. And then we're gonna go back to the workbench, go to the mesh, and basically regenerate it. saves. Yeah, I'm not seeing the line. Update? Okay. Yeah, it's still there, I think. Oh, let's go name sections. I'm not seeing it. Unless this is. We want to name the section. I'm not seeing it. Okay, I made a mistake. I already made the plate like a line, and you need to make it some arbitrary thickness. So I went ahead and did that, but I'm gonna redo it here. So I'm just gonna draw a relation line or draw lines. Horizontal, vertical, connect these lines. So then we're gonna constraints, make this one horizontal. And then we're gonna define this one. We're gonna make it 0.05 inches. So it's small enough that it won't really affect anything. And we're gonna go back, regenerate that. And now we're gonna go back into the mesh and update it. That was my mistake. So you have to like make a hole in the test section basically of your surface, because if you just draw a line, it's not gonna do anything. Now we wait. Make sure this is still recording. Yep. All right, the mesh is done. We're gonna open it up. That's not right. Stand by. We gotta go back to the geometry. I don't know what the world just. Oh, when did that happen? Well, we can fix that. Oh. Oh, I think it made it. Okay, I see. Because this isn't defined, so it thought this line and that little line were parallel. We can fix that. Definitely can fix that. We'll just change this one. So we'll make it like really big. And then, yeah, there we go. I'm sure you can turn that off. Like auto constraints. Okay, again, 0.05 inches. There we go. Great. Okay. Now make sure I should have checked that before. Okay, once I regenerate that, it'll, yeah, okay, awesome. Okay. So we're gonna close this mesh because that's incorrect. We're gonna go back to the workbench, re-update it again. I should have checked the sketch before I went gun ho and made it meshed it. Waiting, still waiting. Okay, cool, it's done. Make sure we're still recording. Yep. Okay, so then now you can see the little sliver. So now we got the 3 from the previous project. We're gonna make one more edge. We're gonna make one more set name section. Zoom in a lot. What is this doing? There we go. Hold control while doing this, and then right click it and hit create name section. We're gonna call this flat plate. Okay. Zoom out. Just hit generate again, just in case. Generate. Okay. I'm gonna close this. I'm also going to close the sketch. So I guess the mesh needs updated again. Or it's doing something. Update. It's probably gonna open the mesh up because I just double clicked it. We can make sure that. Okay. What is this doing? Oh, it's not responding. That's fun. Standby. We are back. I had to task manager close task the mesh. I'm gonna open it to verify that the name section saved, because if it doesn't, you can't move on basically. And it's still there. Awesome. So then we're gonna basically just update the solutions. You don't have to do setup. While it loads. Still loading. Luckily, the project goes by fast after this is all done. Wow, this takes a while. Make sure it's still recording. Oh. So basically what we're gonna do once we get in here is we're gonna create a the drag force. We're gonna solve for the drag force. It's open. I'll just show you. Launch solutions. Just solve for the drag force, and that's gonna be it, really. And then we'll do the streamline afterwards. Okay, so you can see that section or the flat plate right there. We're gonna make sure that the velocity is at 3.3. Yep, that's right. That's because the test will be 12 at 50 hertz. So then we're gonna go to report definitions, double click, new, force, drag force, flat plate, have to have, that's what we did in the mesh. And print to console and plot. Hit compute. Okay. So see, it just gave us the value of the drag force, not the drag coefficient. Drag coefficient, you have to solve in an Excel sheet. All you do is take the force and divide it by dynamic pressure times the height. And for the airfoil, it's gonna be the length. And we'll close this and we're gonna run calculations. So we're just, it's basically redoing project one, because we need the contour for static pressure for the, you'll see what I mean. And here's the graph. Oh, that is, okay. This is the graph for the drag coefficient. And okay, so we're gonna go to graphics, contours, static pressure. And you can see there's a large like vortices being formed because of pressure drag. We're gonna rename this. It's not supposed to be. Can you just hit rename? No, can't. Oh, I guess you can. Drag. You're not capitalizing? Nope. Drag force. We're gonna recompute that again. Okay, I'm not sure why it's not changing the name of it. If I probably close it and rerun it. Nope. That's fun. We're just gonna. Yes. We'll do it again. New force drag. Make sure you name it because I guess you can't rename it afterwards. Force drag. Flat plate. Oh, I had that. I don't think I selected it. You need drag force. Print console. Oh. Calculations again. Yeah, there we go. That yeah. I think I did have drag. I don't think I selected drag coefficient. We're almost done. I just wanted to fix that. So force drag. Interesting. I don't know why it's flat plate drag force. It's still giving me the same value. Interesting. Okay. And then we have static. And then for the streamlines, we're gonna go back out and go to results. And once this is loaded, all you have to do is hit streamlines, streamline 1, all domains, start from velocity inlet, and we want the velocity 25 and apply. And I need to move you. And there it is. That's all you do. So, yep. Thank you for watching. Hello, we will be doing the airfoil for project 2. And so let's just get started. So first, we're gonna pull up the NACA airfoil. It'd probably help if I was sharing my screen. Oh, I am. Okay. So this is the NACA airfoil. I'm choosing the Clark Y. So what you're gonna do is hit format dat file, and this gives you like the X and Y coordinates. So you just copy and paste all this. And create a new Excel sheet. And what you do is you format it in this way. And then copy and paste the coordinates that you just highlighted into X, and then you need to go to comma delim or convert, yeah, this. Hit that, finish, so then it does all that. Put ones for the group all the way down to your last name, but you're gonna want to go one down from the last one. Then 0.1 and then equals 1 or equals that plus 1, and drag that all the way down. And then I believe, yeah, this is all 0. Okay. And then for the last, this has to be 0 because it like has to go back to itself. And you're gonna save this. And then you're just gonna, I'm gonna call this airfoil. So this, I already did this before, but yeah. So this is, you do that, then you save as, you want it as a txt file, or text this one, you want that. Save. And then you go to your workbench, open up the geometry. And we wait for that to open. So I left off with the flat plate, but I went ahead and did the other 2 shapes. So here, and you can see I did the hemisphere. Then we're going to sketch, zoom in. We're going to delete this line, and we're gonna constraint coincident that point to this point. So now our origin has moved to the center of the test section. Can't write down. It's moved to the center of the test section because when you import the airfoil, it goes to the origin. So you need to, and you want the experiment to be the middle of the test section. None of the dimensions have changed. It just has shifted over. So yeah, then we're gonna go to draw. We're gonna delete the hemisphere. So we don't need it anymore. Leave that point, doesn't matter. And then we're gonna go to create or concept, 3D curve. We want from coordinates. We're gonna select the file. Underground. And we want the text file. There we go. The airfoil is in. You can see it. And then you have to hit click this, hit generate. Here it is again. So then we go to what do we need to do? We can make or size it. Scale. We want this. And we want it, so this airfoil is an inch long. And we want it 0.6. So we're gonna scale it by 0.6. And hit generate. So then it just made it really small. Or not really small, but smaller. And we did it by 0.6 because that's what we wanted as the blockage ratio. And then we're gonna go to surface from edges. Generate. Now we have that. Then we're gonna go to Boolean. And we want to not unite, we want to subtract. Target body is the whole thing. Target body. See how it's I like hit it twice. You want to hit the green plane that's saying the other one. Apply. Oh, I didn't take this. Apply. There we go. Then update. And now you can see we basically cut the airfoil, like the shape out of the surface, which is what we did before with the other stuff. So that's done. What else do we need? So yeah, we're done with the sketch. We're gonna go to mesh. Basically, we're just gonna, I don't like how the camera is. We're just gonna update everything basically. Because we already have the graphs for the drag and stuff. So then update the mesh. And zoom in here. Whoa. We want to delete this. And we want to edge. Right click, create named airfoil. And go. I'm gonna generate that again. I don't know if it makes a difference. I think we're good. Go to the workbench, go to solution, yes. It might throw an error. It's what it keeps doing to me is it throws an error and then you have to like you have to just X out and reopen it. We'll see. It might not do it this time. Yeah. Don't worry about that. You can still see the airfoils there, just really small. What do we want? So it's basically saying you had the hemisphere surface that we like name section, but we deleted it. So when we updated this, it's like in SolidWorks with a rebuilding error, right? Yeah, rebuilding error, same concept. We're just gonna delete this and make a new one. It doesn't really matter. It takes like 2 seconds. Force, drag, force, drag, force. All of these. It's not showing up. It didn't update. Oh, that's great. We want to X out of this. There we go. Fluent's not a very nice program. Update. I probably should have waited because I made that. Yeah, I did the mesh. I updated the mesh and changed the name. Probably should do the name, then update it. We're gonna go back to solution. And it should be there now. I don't know why it does this like intro to Fluent thing every time you open up Fluent, especially it exists. I can understand if the uh file's new, but it's not new. See, new force drag. Yeah, so there it is. It just had to rebuild. Drag force, rent console, airfoil. Okay. Close, initialize. Always initialize it first. I've ran into problems if you don't initialize it, it'll make problems. Run calculation, calculate. Now we wait. We can see the drag force graph being created. It might look weird when you first run it. It's just it's because it's hasn't finished its iterations. But anyway, that's the drag force graph. And then we're gonna have we're gonna get the drag force, the actual like average value of it, I think, from the console. And then we'll do the streamline and we'll get the contour for static. So let's start with the contour before I forget. Static pressure. There it is. So you can see there's a lot of pressure at the frontal, like the leading edge of the airfoil. And it's kind of cool. You can see that like the top of the airfoil has lower pressure than the bottom, which that's the whole point of an airfoil, to generate lift. That's how it does it. So I think that's pretty cool. And then we go to reports, drag. We already got the graph. And we're just gonna compute. So you can see the drag force is like, it's way smaller than the other shapes if you've gotten this far, which makes sense. It should be because it's more streamlined. All it has is a frictional drag on it. So yeah, pressure drag is way greater or more significant than friction drag. Anyway, just kind of giving you some reasoning so that you know that like it's working correctly. We're done with that. Go to results. And here's the streamline of it. Again, I think this is kind of cool. You can see that the velocity, it's really small, but the velocity increases over the top part of the airfoil, which again makes sense with Bernoulli's. If velocity increases, the pressure has to decrease. If you look at the contour, those relate. So, and that's why lift is generated. So I think that's kind of cool again. And that's it.